and a significant amount of analysis. So that brings us to here. So this is the nationwide network of seismic stations that we use to monitor earthquakes and other phenomena at a national level. Again, unsurprisingly, you'll see there's a ton of those red triangles on the West Coast where we monitor the San Andreas Fault region. But you'll also notice there are some areas in Texas and Oklahoma, again, where there have been some intentional increases in seismic monitoring, specifically for the purposes of monitoring induced seismicity. You will note that Louisiana there are just 3 stations listed there, and my understanding is that one of those is not currently operational, so there are currently 2 stations from the national network that are operating in Louisiana. And so if you'll forgive an analogy here, for induced seismicity operations, this is kind of like driving a car and if you imagine the temperature gauge in your car, this is like having a temperature gauge where you can only see the red, right? We can right now only detect large earthquakes so that we're already having, that are already, very close to causing problems, right? So this is like only having a gauge that tells you when your car is already dangerously overheated. With the addition of stations such as our sister states have done, then that's sort of effectively like expanding your threshold of what you're able to measure so that hopefully you could be able to see when you are approaching having a situation of concern and then make choices to hopefully avoid having long-term consequences like having a damaging earthquake occur. And so I will leave my remarks there and leave it to my colleague to explain about what's been happening in Louisiana this year.
Real quick, Ms.
Yes, sir.
Luttrell, you said we can only detect larger earthquakes here in Louisiana. That's our detection capabilities at the moment. Because I know out west, I lived out west for a portion of time, they can detect, 1.5, 2.5, whatever it may be. So we're somewhat limited here in Louisiana, and probably because the occasion of earthquakes is fairly rare.
Right. So it has. These are the sorts of things we do not carpet the entire continent with instrumentation equally, right? So you're right. In areas that are really have a lot of intense seismic activity, like in California or Japan, then the joke is you can't walk around without tripping over a geophysical instrument. We have not thus far had an occasion to do that formally in Louisiana. Some of our sister states have decided that they needed to do that, as you saw that build out. So, but yeah, no,
Very
that has
good.
not happened in Louisiana.
And it's the recent cluster that's kind of why we're here to discuss this, try
Correct.
to get to the nub of what's going on. Thank you for that, Dr. Luttrell.
Yeah.
Dr. Eminger, would you please state your name for the record?
Hello, I'm Dr. Cynthia Ebinger. I'm from Tulane University. I'm a geophysicist, and I am going to show you the data that that we've all been hearing about. And so we can look at some facts and hopefully put this all, with that context, start to understand what has been happening in the state. Great. Let me just, whoops, there we go. I have considerable experience over several decades working in plate boundary areas where earthquakes, volcanic eruptions, and landslides are not uncommon. So I have not only worked to understand the processes, but also worked with communities in the aftermath of disasters. So what I have been doing in Northwest Louisiana is try to collect data that helps us make informed decisions. On March 5th, early in the morning, seismometers across the U.S., because the earthquake was large enough to be detected across the U.S. A seismometer in Shreveport deployed by the Arkansas Geological Survey detected the earthquake. That's the one at the bottom. No, the one at the top is Shreveport. The next one is in Carthage, Texas, and the other one is over near Timpson, Texas. But if you see that there was over a minute of intense shaking, so the wiggles that or have kind of a bell shape, and they're in effect they're like a bell ringing with the same pitch over an extended period of time. That was shaking for about a minute. So this is what was felt in Northwest Louisiana. So ignore the top 3 traces. We don't need to go into that. Partly owing to social media posts and partly owing to just general information, people across Northwest Louisiana and eastern Texas went to the U.S. Geological Survey and entered information on a little survey saying what they experienced. And that enabled the U.S. Geological Survey to come up with a map of the intensity of ground shaking. So let me just explain a little bit. There are things like plates rattling. That's one level of shaking. If it's enough for the refrigerator door with a seal to bounce open and close again, that's a much stronger ground shaking, and these are just uniform things that we can use. So this is what respondents replied to, and this is the area impacted at 5:30 in the morning on a Thursday morning. If it had happened during the middle of the day, there might have been 10 times as many respondents. But you can see that the ground shaking was moderate to intense in areas very near to where the earthquake epicenter is. And you can see the star. That's the location of the earthquake at Earth's surface. But earthquakes occur below the surface, so that's just a representation. Okay. So up on the top, it's just another picture explaining how a magnitude 2 earthquake is 10 times smaller than a magnitude 3, and just showing with balloons how by the time we got to this magnitude 4.9, how much bigger it was than say a magnitude 3.9. So physics says that injection of any fluid into Earth's subsurface increases the pressure. If the pressure exceeds the strength of the rocks will break. If a patch of rocks break, it causes an earthquake. The larger the patch of rock that breaks, the larger the magnitude of the earthquake, the more earthquake shaking that occurs, the longer the duration of shaking, the more potential damage that can occur. So, when we see an increase in the number and magnitude of small earthquakes, little earthquakes mean there's an area of the ground that is susceptible and it's to be watched. But if an increase in number and magnitude, it means that the pressures are increasing. That is without a doubt a fact. So what I try to do is detect small earthquakes and say, these are areas where pressure is increasing. Let's pay attention to these areas, maybe perhaps modify our activities or at least prepare for a situation, okay? So our ability to detect depends on the size of the earthquakes, their magnitude. So if it's very small, we need a lot of instruments close together. The USGS can only locate earthquakes in Louisiana with a magnitude greater than 2.5. But if I get research funding and put seismometers out, I can detect earthquakes of magnitude 0.5, magnitude less than 1. And I can start to see places where pressure is increasing. So what have I done? Well, in 2019 to 2021, I had a small array out in northwestern Louisiana. We had 14 stations out just to see what was happening in Louisiana, and we saw some areas with small earthquakes. We saw one near the Texas border and in the Coushatta area. And there were some others, but they were just like a single earthquake, nothing that we were so concerned about, and we reported to the state. Meanwhile, time's gone on, and I got additional funding as the number of earthquakes were reported by the U.S. Geological Survey started to increase. I got a small grant, and I put 7 seismometers out, And we have detected 116 earthquakes since last October, whereas the U.S. Geological Survey has only detected about 50. So we've doubled the number, and we're able to see areas where the pressure is increasing. Now, that timeline that you can see up there, the number and magnitude of earthquakes, magnitude isn't shown, but the number has very definitely increased since 2021, and 100 earthquakes that should be since, it shouldn't be November, it should be December. Sorry, that was an edit mistake. And just to say that my work so far has shown that the depths reported by the U.S. Geological Survey are the same as what we're determining. Now, in March, we had our first earthquake, and I just want to explain one more thing. We talk about a main shock, and then there are adjustment earthquakes that happen afterward, but they are generally an order of magnitude, meaning if there's a 4.9, we'd expect aftershocks to be 3.5, 3.7. But instead, 3 days later, there was a 3.1, 3.2, 4.1, 4.4 that's almost as large as the first earthquake. That type of earthquake pattern is more like a swarm. We see those on volcanoes where we have pressurized fluids in the subsurface, and we have seen them in other areas where there is wastewater injection or fracking occurring, where fluids in the subsurface may be involved. I'm not saying we can prove that. I'm showing you some data and giving you an indication of some of the additional research that can be done to help answer questions. Okay, so you want to know what we found. In red are earthquakes detected by the U.S. Geological Survey between 2022 and 2025. In blue are 2019 to 2022, when we first started to see earthquakes in Louisiana. You can see that the blue, the red, and the green are what I've been recording since October, the end of October. In black are known faults in the Louisiana Geological Survey database. Yet, if you look at Coushatta, there's a northeast striking fault that's well known by operators, by geologists and others in the subsurface that isn't on that map. There's probably another one up by Ringgold where you see another cluster of earthquakes. The earthquakes up at the Texas border, those are along known faults, and they make sense. And the box is the piece where I am pointing out, this is new information on the number of earthquakes along that fault system in the Pelican area of south of Coushatta on a different fault. And those are small earthquakes right now, but there are a lot of them. Okay, so I'm going to blow up. Oh, sorry, this is so just wanted to say, too, that the instrumentation that's out after the March earthquake, because I had instruments out, I went out to help the U.S. Geological Survey. They also telemetered some of my stations, so it's going directly to the U.S. Geological Survey to assist in rapid rapid location. And this is just the team that's out giving you an idea of the size and the scale of the instruments. That kind of triangular thing in black, that's the cell phone telemetry system. This is probably the blow-up you want to see. There's Coushatta, the earlier earthquakes in blue from 2019, the swarm in 2021, then 2022 to 2024. The green are what happened in March. And then the green are the second, it's this other group of earthquakes that hadn't been reported before that you are seeing, you're seeing for the first time. And then they're shown over on a map on the left on a Google Earth map, so you can start to place them in terms of geographic markers that you might be more familiar with. And you can see the Red River coming down with the wiggles there, and it's coming, Natchitoches is just off the map to the right-hand side. I think that's all, just to say that there are areas in Louisiana in this reclaimed coal mine area where the soil's weak, the ground is weak, and there was damage. So earthquakes can happen, and can cause, this earthquake did cause local damage and some timberland. So I just wanted to raise your awareness of the potential in Northwest Louisiana. So thank you.
Thank you for that, Dr. Ebinger. The sensors that you put up when you received the grant, and you put some sensors out, is that correct? Mm-hmm. Okay. And they were able to detect 0.5 and higher?
Yes, they were.
Okay. Are those reported to the USGS? Just curious.
So the U.S. Geological Survey is a typical situation. Tulane University owns the seismometers that I use for research experiments. They were part of my startup research package. So I got funding to deploy them, and as in terms of the agreement, there weren't really funds available. It was a small grant that didn't cover the cost of telemetry, and nor does the U.S. Geological Survey normally process information from local arrays. So scientists do their research, they report their findings, the data is archived with the U.S. Geological Survey, but we don't normally add into it. It's a lot of extra work for them.
Yeah, it's not an immediate reporting as it is for the larger, was it 2.5, Dr. Luttrell? Mm-hmm. They have sensors for that, which is automatic reporting, whereas your smaller sensors aren't doing that. You're basically collecting data and passing it along?
Well, I think the smaller sensor, it's not the size of the sensors, it's the spacing between them. So the closer they are, the smaller the earthquake. The U.S. Geological Survey is operating 2 seismometers in the state. Without Texas and Arkansas having denser arrays, they wouldn't even be able to locate magnitude 2.5.
So it's a density of
the density of the stations.
So the ability to monitor is the same. It's the density which detects the smaller magnitude.
So I would add.
Hold on. There you go. Dr. Luttrell.
Sorry. So if I can add, and the difference is that the USGS operated stations are automatically plugged into their workflow, right? So that's why they can report earthquakes in near real time, right? As opposed to the sort of academic networks, even once the data is telemetered, it's still it's sort of a scientific expertise workflow issue and such, and so those are not automatically plugged into sort of long-term, national level operations, although in some cases they, end up becoming that way if these things end up becoming permanent, but that's not a standard thing that would automatically happen.
I'm going to get.
Okay. In another area, I was thinking if the magnitude and frequencies of these are increasing, is there something in our building codes, or do y'all talk with them about how we should be designing roads and bridges and homes and whatnot to account for increased or magnitude or frequency? Do y'all have any collaboration with?
I'd add one more piece to this to say that this is something, it doesn't necessarily keep me awake at night, but it bothers me that the fault in Coushatta ruptured most likely under the Red River, meaning that it ruptured under the levees to the Red River. And those are soft earthen structures that are susceptible to shaking, right? So it's what structures do we have, what are building codes? And I don't know. It's well outside my field to know what the building codes are, but I am aware of the material properties of the surface, the mined area, the reclaimed land, and the levees are the softest pieces out there, and those are my biggest concerns right now.
So we need to be thinking about that, okay. And lastly, I'm thinking about how we've thought things over time and been challenged on the validity of our assumptions. And I want to make sure we're careful not to jump right in and say this is the fault of exploration and production or whatever, when it could just be we've got more monitoring, more people reporting. I don't know. I just want to make sure we don't jump to some conclusion and go off the wrong way there. So I just encourage you to have an open mind, as well as we do, to make sure that we don't say, oh, this is the reason for all this right here. Let's just stop it or restrict it or whatever. And I'm wondering how far our data goes back. Is this just the earth moving as normal processes, or are we exacerbating the problem? And I don't want to jump one way or the other. So.
And if I may respond to that, I think you're absolutely right, and I think that has, formed sort of the core of the agency's response. Is we want to make sure that we're gathering all the information we can and that we're sharing it with researchers like Dr. Luttrell and Dr. Ebinger, so that any assumptions or any evaluations that are made with data and aren't just being driven by a knee-jerk response.
Okay. Well, thank you again. Appreciate it.
And just to piggyback on what Representative Cruz said, is that is important because we are an oil and gas state.
Mm-hmm.
And we're all proponents of it. We want to make sure that we're doing everything properly, and everyone else is safe in the process as we do that. We're going to go now to Representative Amedee.
Thank you, Mr. Chair. Good morning. I just want you to know that looking at pictures like this brings me right back to 5th grade.